All right, this week we will go through the kinetics of particle and force and acceleration in part 2. Let's remember what did we do last week. Last week we go through the equation of motion in rectangular coordinates. And in rectangular coordinates, how we are going to define it in I and J and K with the unit vectors in X, Y, Z direction. And we said that from the Newton's formula, we know that the total force in X direction is X direction acceleration multiplied by mass. Y total force in Y direction is equal to Y direction acceleration multiplied by mass, and again similarly for Z direction acceleration multiplied by mass is going to give us the total force in Z direction. So acceleration vector is given by the AX, AY, AZ in I, J, K unit vectors, and the magnitude we can find it. And total force is gonna give again in the I, J, K directions, and total force magnitude is gonna give square root of X direction force square plus Y direction square and plus Z direction force square of total square root is going to give us the magnitude of the force. We know that this one from our physics 1 class, so I'm not going to go detail anymore. And we say how we are going to act to solve this kind of kinetics problems. We will draw a free body diagram and equation of motion. We will say for the spring and friction we define it and how we are gonna approach for these guys, and we will use the kinematics terms from previous classes, and then we will define our velocity, acceleration and position. Then we will start to solve for the kinetics part. That's all the way we cover, and we solve these questions as you remember. Today, let's start with solving the other question, other example 4, and we will keep going. Okay, let's jump to solution of this question, which is 4 cars. This guy's mass is 400 kilogram, and the velocity is in the up direction, upward 2 meters per second, and the force in the cable is 3200 t square is given, like force is given by function of time, and where t is in seconds, and we are gonna find the velocity and the position at time is equal to 2 seconds. And as you see here, the angle of this inclined surface is 8, 15, 7 triangles. So like, okay, let's jump to solution. Okay, in this question is asking the velocity and position at time is equal to 2 seconds. Okay, we know that the force is 3200 t square. The initial velocity is 2 meters per second. The position we can, if it is not given, we can directly taken by 0. So let's start to solve. First of all, we need to find let's draw first the free body diagram. Let's draw our this ore car. We know that there is an tension in this direction, right? So we know that the coordinates is like here we can take it x, here is take it y, and we have that angle which is 8 and 15, which is here 17. So this is the angle, let's say. We have the mass, which is 400 multiplied by g in this direction, but we need to find also the normal direction is gonna be here, right? So there's gonna be coincidence like that. But we need to multiply by cosine theta. So in order to find the normal direction, we know that from 8, 15 and 17 is the angle of somehow. How we are gonna draw? Let's draw from here. We see here, here, and then we want to find that guy, right? The angle between this one and that one. Or let's draw a little bit down here and here, which is normal, and then mg is coming in this way. Let's pretend. So we know that from z is gonna be here is theta, which is 815, right? So from the normal one we can take it again over here. So it's gonna be like when we have this one, we can say the total force is equal to, right now we are writing our equilibrium equation of motion. Total force is equal to T, which is tension, minus, because tension is going to upside, right? Upside. And minus mg. Right now we need to multiply by the sine theta in order to get this term, right? So it's gonna be 8 over 17. 8 over 17 is equal to m and a in x direction, right? So x direction motion. All right. Tension, which is the force here, is 3200 t square minus m is 400 kilogram, 400 multiplied by g, which is 9.81, and we need to multiply by 8 over 17, which is equal to 400. And what we need to find the x direction acceleration, right? So when we manipulate it, let's see what's we will have. Ax is equal to 8t square, 8t square minus 4.616, 4.616. Again, ax, we get it in t, function of t, which is meter per second square as the unit. So okay, if we find the ax, we want to find the velocity first, because the question is find the velocity and position. For velocity, we know that is v0 plus integral of from 0 to t, whatever the t time is given, a dt is gonna give us the velocity at time, this time period. Okay, v is equal to, our first velocity is 2 plus the integral of from 0 to t, the parenthesis is 8t square 4.616 dt. So the result of velocity is 2 plus 8 over 3 t cube, right, and minus 4616 t is gonna give us the velocity function of time at time is equal to 2. Then we are just gonna plug this velocity t is equal to 2. Then our velocity is gonna be 14.1 meter per second. Okay. So if we want to find the position, is position again as 0 plus the integral of from 0 to t s is velocity dt. Velocity, we know that s0 is 0, we just plug it, and from 0 to t, the integral of 0 to t, the velocity term here with time function of time 8 over 3 t cube minus 4616 t plus 2 dt is gonna give us the position function, which is gonna be 8 over 12 t4 and 416, so it's gonna be minus 2.308 t square and plus 2t is gonna give us the position function at time is equal to 2. So we can find our position is 5.43 meter. This is gonna be our position at time 2 seconds, and time is equal to 2 seconds. The velocity is 14.1 meter per second. So we already calculated both position and velocity at time 2 seconds with given function, with given force and the initial velocity. Okay, when we jump to equation of motion in normal and tangential coordinate, we remember from our kinematics part classes, we have the tangential and normal coordinates and how we are going to define all these terms. If you don't remember, you guys can go back to the videos so you guys can watch it again, how we define this normal and tangential. And also, as you see here, the curvilinear motion, right? Curvilinear motion here. And so from this line, we know that the tangential direction is that guy, and then the 90 degree, which is the normal degree, normal angle, the normal direction is given. And also the third direction is in the z direction, which is the above of this plane, is gonna given by the b, or just you can say z. But we have the motion in the two-dimensional, which is t and n. So in AT is gonna give us the total force in tangential direction, and ANM mass with a normal direction acceleration is gonna give us normal direction force, which is called also the centripetal force. And then the last one is there is no motion in the y direction, or if there is motion, it's going to be constant. But there is no motion here, as you see here. Is centripetal is going to pull in the downside, normal side, and the tangential is going to go outside. Or like if it comes here, the tangential direction and normal direction, because this force wants to take is inside, but it's gonna pull outside. The resistance is gonna give us the outside direction, and but the mass wants to pull it in the downside. Never mind. So that's why the FB, the total force on z direction is 0. And also we have the total force is equal to ma as the Newton's formula, and we can solve it in tangential and normal direction coordinate. Ft ut, the unit vector in tangential direction multiplied by the magnitude of force in tangential direction plus Fnu and Fbuv is equal to, in tangential direction acceleration and normal direction acceleration, as we see is, and again in this curvilinear path there is no motion in B, so that's why we don't need to write AB. All right, let's jump to other slide. In here, again, the same thing what we solve. Again, the same thing is F is equal to ma, and then we open the open form of this representation, and it's given the what is this total of Fd, Fn, and Fp, which is 0. So like the normal force, as again we said, is a centripetal force, is total Fn, normal direction, total normal direction, acceleration. And how we are gonna find at, the tangential acceleration, as we remember the velocity at this point, the first derivative of this first time derivative of velocity at this point P, and at is equal to, if you want to make it with the ds instead of dt, v dv ds is gonna give us our tangential acceleration. If we want to know the normal acceleration, is gonna be v square over rho. It's constant, as we know. So if it doesn't change with the time, it's fine. We just need to plug it, and then we will find if even though constant velocity is gonna give us normal acceleration, we solve it in kinematics part. And the radius of curvature is gonna give us 1 plus dv dx square, and in the parentheses of power of 3 over 3 over the second derivative of y over x, y with respect to x, is gonna give us radius of curvature. This all stuff is from our kinematics part. Okay, in this question, first of all, let's stop here. Let's go through with this one. Okay, we have again curvilinear motion, and the ball A is moving 3 meters per second, and the length of the curve, or the radius of curvature, is 2 meters. Is given. We are gonna find the tension in the cord and the increase in the speed of the ball. We are gonna calculate it. Let's start with the free body diagram. We know that we have a ball A is located here, so the weight of ball is on the minus y direction, and the tension is gonna be like that one, and it's making 45 degree with the horizontal, right? So as you see here, 45 is again the same thing here, 45 degree with the horizontal, and that's it. Like there's nothing, like it's not on the surface, nothing. So it's gonna be fixed in O and is moving with the on the air. So there is no normal force acting on it or friction acting on it. Nothing. We just need to writing down our equation of motion. So we have equation of motion in tangential and normal direction. So let's go through first of all normal direction. The total force in normal direction is mass multiplied by normal direction acceleration, right? And also the mass is 10 kilogram is given. Okay, and the equation of motion is tension. This is a tension multiplied by let's say if we multiply by the weight, so it's gonna be minus weight sine 45 or cosine 45 is fine. It's gonna be sine 45, right? So it's gonna be in this direction minus this direction. So it's gonna be sine 45 is gonna give us the MAN. So okay, 10, which is the mass of this ball, multiplied by the normal acceleration is v square over rho. We know that v is 3 square over rho. Rho is 2 here, which was radius of curve, which is 2 meters, is equal to the tension, which is we don't know, minus the weight. The weight is 10 multiplied by 9.81, which is mg, multiplied by sine 45, right? And if we do all this mathematical multiplication, all this process, we will find T is equal to 114 Newton. Okay, we find here the tension in the court. So let's go through the let's go here. I can't solve here. Let's go through the force in tangential, the total force in tangential direction. So it's gonna be MAT, which is tangential direction acceleration, is equal to, what is it? So its normal direction is in this direction, right? But due to the weight is gonna go in the tangential direction as well. So when you draw, we are gonna draw in normal and tangential direction. So tangential direction only the weight multiplied by cosine 45, which is given us the here, right? So the weight is that guy, and then as you see the tangent theta is here. So here is our z, right? So this is the 45, also this is 45, doesn't matter. So if you make it cosine, it's gonna be that guy, and we will have the tangent direction, and when we multiply by sine, we are gonna have normal direction. Okay, let's multiply by w cosine theta 45 is gonna give mat is equal to mg cosine 45, m and m is gone, so at is g multiplied by sine 45, which is 9.81, multiplied by cosine 45 is gonna be 6.94. 6.94 meter per second square. So what is the question? The increase in the speed of the ball. So increase is 6.94 meter per second square. What is it? Meter per second is the velocity, right? In per second, 6.94 velocity changing by unit time, which is in seconds. Okay, we found these two term, tension and then the increase in the velocity. Okay, in the second example, we have a car on again curvilinear path. This car has 800 kilogram and traveling over a hill with the shape of a parabola. When the car is at point A, which here, it is the velocity is 9.9 meter per second and the acceleration is 3 meter per second square. We are gonna neglect the size of the car. We are gonna find the resultant normal force and resultant frictional force exerted on the road at point A by the car. Okay, let's first of all let's define our coordinate system. Our coordinate system normal direction and is going to go tangential direction at point A. So we are gonna not use x and y. We are gonna use n and t in order to find our normal force acting on it. But we are gonna use this y and x due to we are gonna find radius of curvature, right? With given formula. Okay, so let's find first of all the let's draw also our free body diagram. We know that the weight of the car is on this direction, right? The frictional force is gonna be in tangential, minus tangential direction, F. And that's it for right now. Frictional force, but the motor is gonna give us force in this direction. We know that, but let's drop right now because there is no external force. We are gonna calculate it force by the motor. So first of all, let's go through again the normal direction, total force in normal direction, which is, we know that mass multiplied by the normal direction acceleration is equal to the velocity, the weight of this car, and is gonna be again normal is gonna be over here, right? So weight multiplied by cosine theta, which is, we are gonna calculate it because we know that here is 80, but in x direction we will calculate from this formula what is the, when we plug 80, what's given y. So we know that cosine theta is x with hypotenuse, so we will calculate from that one, and it's gonna be minus the cosine w cosine theta minus m. What else we are gonna do? Okay, here is 800. We know that the mass of this car is 800, and acceleration is 9.81. Sorry, due to the normal acceleration is gonna be velocity square over the radius of curvature, so it's gonna be 9 square over rho right now we are just gonna drop like this. We are not gonna plug, and we will put later because we don't know yet. After we calculated this guy, then we will plug it and then we will see. And 800 here is mg is 800 multiplied by 9.81 multiply again cosine theta minus n, right? So n is equal to when you multiply these guys 7,848 cosine theta minus 64,800 overall. So this is our normal force acting on the car. Just drop this one for right now, and let's pass the tangential direction. What is tangential direction? After that we will calculate the radius of curvature and then we will just plug it. Which is, we know that MAT, tangential direction acceleration, is equal to, we have here W sine theta, which is given by the weight minus the friction, right? Because we don't have any external forces on it. M is again 800. The acceleration is given by 3, which is in the question is given. As you see, acceleration is 3, is equal to mg, which is 800 again, multiplied by 9.81, multiplied by sine theta minus friction factor, friction force, FF. So FF is equal to 7,848. 7,848 multiplied by sine theta. We are gonna calculate theta, how we are gonna do it. Sine theta and minus 2,400 from this side. So we found the friction force and normal force acting on the car, but we need to continue to in order to find our theta and radius of curvature. We know that y is equal to 20 multiplied by 1 minus x square over 6,000, x square over 6,400. And we know that radius of curvature is parenthesis 1 plus the first derivative of y with respect to x, and parenthesis square power of 3 over 2 over the second derivative of y with respect to x is gonna give us radius of curvature. Okay, let's do this mathematical process. So if we do the first derivative of y with respect to x, let's solve here, is gonna be minus 40x over 6400. And if we take the second derivative of y with respect to x, is gonna be minus 40 over 6400. Okay, let's plug this radius of curvature. So it's gonna be 1 plus the first derivative, which is minus 40x over 6400 square power of 3 over 2 over the second derivative in the absolute value, minus 40 over 6400. So, and we know that before we do this guy, we know that at x is equal to 80 meter, right? Let's show in the graphic again. As you see here, x is 80 meter, so we are just gonna plug the x is equal to 80 meter, so the radius of curvature, when you plug here 80, is gonna be 223.8 meter is gonna be our radius of curvature. And after that one, we know that, as you know, from the triangle, now is gonna be, here is dx, here is dy, right? So tangent theta is equal to dy over dx, which is the if we take the first derivative of y with respect to x. So if we want to find the theta, it's gonna be arctangent or reverse tangent dy over dx. All right. So when we plug dy dx at 80, as we know, so the theta is equal to arctangent minus 0.5 is gonna be equal to 26.6 degree. So we know that theta right now, we know that rho. So if you plug the above equation and friction force, if you plug, it's on you right now, I'm just gonna give the result, and is gonna be normal force is gonna be 6,200, sorry, 6,728 Newton, and friction force is 1,114. Sorry, 1,114 Newton. All right. So we found a normal force and frictional force for given hill or for given path. What about in cylindrical coordinates? Again, from our kinematics part, we already defined. Right now, it's not in the curve path. It's also moving in the x direction, z direction. So we will have Fr ur, F theta u theta plus Fz uz. So it's gonna be MAR UR theta direction acceleration multiplied by mass with theta direction unit vector and z direction unit vector, z direction acceleration and total mass. That mass. So if it is like 1-by-1 match, is gonna give one over here. So everything is clear here. We don't need anything. We just need to know that a cylindrical coordinate is the r, theta, and z direction. If it is polar coordinate, it's just gonna be r and theta. If it is cylindrical coordinate, it's gonna be r, theta, z direction. That's only thing we will know. Like we can jump to example and then we can solve examples. Then we can solve. We can understand better. Okay, here is your quiz. We have 2 kilograms of a block B and 15 kilograms of cylinder is in the bottom of the table, are connected to a light cord that passes through a hole in the center of the smooth table from here. Okay, if the block travels along a circular path of radius 1.5 meter, determine the speed of block. So we are gonna find the speed of this block if we have 15 kilogram cylinder and 2 kilogram of block. Try to find and send it to our box. All right.